In this video, we're going to find all of the x and y intercepts for the function f of x is equal to 2x to the 3 plus 2x squared minus 24x. Now, in order to find the x-intercepts or the y-intercept of this polynomial function that we have, we're going to do it the same way that we have applied this principle to any other type of function or type of equation. What we're going to do to find the x-intercept is we're just going to put, or potentially intercepts, is to put 0 in the place of y, or in this case in the place of f of x, because those are interchangeable, and solve for x. That will give us an intercept if there is one, or multiples, or a single one, whatever the case may be. To find the y-intercept, we're going to put 0 in the place of x and solve for y, and that's going to tell us where we run into the y-axis or where our y-intercept is. So in general, if you're ever looking for intercepts, you just want to put 0 in the opposite variable from the one that you're looking for, and then solve, and that's going to tell you where any kind of intersections are going to happen on those axes, i.e. where the intercepts are. So let's go ahead and do this for the x-intercepts first. So like I said, f of x, you can think of it for purposes of this class as the same thing as y. So we're going to put 0 in the place of f of x. So 0 is equal to 2x to the 3 plus 2x squared minus 24x. And so just like we had in a lot of situations with quadratics, here we have a polynomial equation equal to 0, and we want to solve for x. We want to figure out what x values give us a y value of 0. And so what we need to aim to do is we need to aim to factor in some kind of way so that we can have 0 equaling a product of factors, and then we can set each of those factors equal to 0 separately using the zero product principle. And so in order to factor this particular problem, we're just going to bring the 0 down first of all. On the right hand side, we have a third power, so we have a cubic. And what we want to do is let's look and see if we can find a greatest common factor to factor out of all three of these terms. So we can definitely factor a 2 out because a 2, and a 24 are all divisible by 2. We can also factor an x out of all three terms because there's an x to the 3, an x to the 2, and an x to the first power. So we can definitely pull or divide away an x from all of those. So our greatest common factor is going to be 2x, and that's going to be multiplied by what's left over. So when you divide 2x to the 3 by 2x, that's just going to be left with x squared. When you divide 2x squared, 2x away from 2x squared, we're going to be left with just x. And when you divide 2x away from negative 24x, you're going to be left with minus 12. And so 2x to the 3 plus 2x squared minus 24x turned into 2x multiplied by x squared plus x minus 12. So we have two things multiplied together now, but one of those things is a quadratic, so we would still have to set it equal to 0. So in other words, we can factor more. So let's go ahead and do what else we can do. So leave the 2x alone. We can factor the x squared plus x minus 12 into x plus 4 and x minus 3. So the x plus 4, because positive 4 minus 3 gives us the positive 1 right here, and positive 4 multiplied by a negative 3 gives us the negative 12 found right there. So that's why that works. So now we have factors on the right hand side, but they're all linear. So now we can set each of those factors equal to 0 and solve for the various x-intercepts that we'll have. So that's what you want to do. You want to factor until you just have a product of linear factors and then set each of those equal to 0. So we're going to do it separately. We'll set the 2x equal to 0, then the x plus 4, and then the x minus 3. Like I said, taking advantage of our zero product property. So 2x being set equal to 0, we would divide both sides by 2 and get x is equal to 0. So that is our first x-intercept. The second one is found by putting x plus 4 equal to 0 and subtracting 4 from both sides. That gives us x is equal to negative 4. So that is our second x-intercept. And then the final x-intercept will be found by putting x minus 3 equal to 0. Adding 3 to both sides, we get x is equal to positive 3. And so x equals positive 3 is going to be our third and final x-intercept. So we have x equals 0, x equals 3, and x equals negative 4. So those are the locations on the x-axis where this function is going to touch or cross the x-axis. So now we've done with the x-intercept, so let's talk about the y-intercepts, or y-intercept. And the reason that it's always going to be y-intercept is because we're dealing with functions now. And functions have to pass the vertical line test. So you couldn't have two different places where your function ran into the y-axis, or then it wouldn't pass the vertical line test and therefore not be a function. So it's okay to have multiple x-intercepts now that we're in the world of functions, but you're only ever going to have one y-intercept. And you're going to see it, if you do what the process is, just put 0 in the place of x, you'll see it's always going to boil down to one answer. So essentially what we're doing, putting 0 in the place of x, is the same thing as evaluating the f of 0. So the f of 0 is going to be, instead of 2x to the 3, it's going to be 2 multiplied by 0 to the 3, plus, instead of 2x to the 2, it's going to be 2 multiplied by 0 to the 2, and then minus 24. Instead of 24 times x, it'll be 24 times 0. Now, the really nice thing about this is all of these terms are going to zero out, because 0 to the third power is 0 multiplied by 2 is still 0. 0 to the second power is 0 multiplied by 2 is still 0. And negative 24 multiplied by 0 is still 0. So the f of 0, or our y-intercept, is going to occur at the y value of 0. So the point there would be the origin. So you can notice right here, this is going to be a y value. You can see that this function essentially runs into the origin, because we have an x-intercept at 0, x equals 0, and a y-intercept at y equals 0. So that tells us it's going to run through the origin point. So that's it. That's all you have to do. Just substitute in 0 in the opposite variable and solve, and that's going to always give you your respective intercepts, whichever ones you're talking about. And like I said, you can have multiple x-intercepts, but you're only ever going to have one y-intercept, because we are talking about functions now.